right, ladies and gentlemen, let's look at the first, this is number 4, but it's actually the first full hypothesis testing problem we're going to do. All right, so I'm going to have you pause the video and just read through this, make note of any information you may need and so forth, and then we'll go from there and then restart the video. Okay, so what we did, a study, I got to read through this just for my own sake, but a study published in the American Journal of Psychiatry and a study published in the American Journal of Psychiatry, researchers wanted to measure the effect of alcohol on the development of the hippocampal region in adolescence. The hippocampus is the portion of the brain responsible for long-term memory storage. The researchers randomly selected 12 individuals, so our sample size is 12, with alcohol use disorders. They wanted to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal value. So I'm going to underline that right there. Were less than the normal value of 9.02 cubic centimeters. An analysis of the sample data reveals that the hippocampal volume is approximately 8.10 cubic inches and a standard deviation of 0.7 cubic inches. I forgot to put the labels on there. So, conduct the appropriate test. Our alpha level is 0.01. That's our level of significance. Okay? So let's start first off. Part A and B said to make sure you know what population parameter you're testing and then write the null and alternative hypothesis. Well, when they're talking about average values here, these are not proportions, they're not standard deviations, and again, we're talking about population means. So in essence, what we are dealing with here is a population mean. So I'm going to put, this would be step A and B right here. So the null hypothesis, ladies and gentlemen, would be that the mean hippocampal volume was 9.02 cubic centimeters. Okay? Now, the alternative comes from this. They were testing whether in alcoholic adolescents, that volume was less than normal. So that's going to be our alternative here. And we're going to see if our sample data supports that or not. And if it rejects the null. So the average hippocampal value would be less than 9.02 cubic centimeters. All right. Now, C says, ladies and gentlemen, go ahead and figure out what your significance level was. Well, it was just stated right here, ladies and gentlemen. Our significance level, our alpha, is 0.01. Again, if it's not given, we assume it to be 0.05. So now we need to look at part D in our steps, was the requirements to be able to do a hypothesis test here, because we need a normal distribution, a normal t distribution. Well, if you take a look back up here, ladies and gentlemen, it did say that right here that it's a wait, where did it go here? Oh, that reveals that the hippocampal volume is approximately normal. So we do have a normal distribution. Even though our sample size was less than 30, we do have a normal distribution. And I'm trying to see up here if it says anywhere. Oh, here it does. That the researchers randomly selected 12 individuals. So therefore, ladies and gentlemen, the requirements that we need to be met to be able to do this test are met. And what were they? We have a simple random sample, because the individuals were selected at random, and the distribution is approximately normal. All right. Now, what I mean by normal is not the normal value, but that the distribution seems to be fairly bell-shaped in the board. So now, I'm going to go ahead and draw a picture here. You don't have to, and actually I'm going to go to the next slide to do it, so I might be going back and forth between slides. But what we have, ladies and gentlemen, is this. We have a normal t distribution, and this would be step E. okay? We have a normal t distribution here. And this is t. Now, again, where's our alpha at? Because, ladies and gentlemen, in the alternative it's less than, that means the alpha is going to be on the left tail. That's where our kind of, we call it our rejection region is at. So alpha is here. Now, if we end up with a p-value that's less than 0.01, then, ladies and gentlemen, we're going to end up rejecting. We have sample evidence that's strong enough to reject the null hypothesis. And remember, on this t distribution, ladies and gentlemen, it goes by degrees of freedom, which is the sample size minus 1, which is 11. So we got to make sure we remember that when we go in and find our test statistic, our p-value. All right. So now, next step is to calculate your t statistic. This is F, and I may go over 7 minutes here, but I don't want to split these videos. I want to go one problem per video, so it may go just a little bit longer than that. But again, our t statistic is equal to the sample mean minus the hypothesized mean from the null hypothesis divided by the sample standard deviation all over the square root of the sample size. Okay? So in this case, the mean of the sample was 8.10 minus our hypothesized mean, which we get from the null hypothesis, was 9.02. It'll always come from that. Divided by the sample standard deviation all over the square root of the sample size. Not the degrees of freedom, the sample size is 12. And if we do this, we get negative 4.553. Now, that means that our sample data happens to be more than 4.5 standard errors away from the middle of this distribution. So in order to figure out what that p-value is, the probability that we get a sample data that's more extreme than this, we have to go to our stat app. All right. So I'm gonna go over to my computer, and we're just gonna go to our stat app. So I need to get here. I need to go to the R2Stat app. We're going to go down to a t distribution. And we're going to go to find probability, because that's what a p-value is. It's a probability value. Now, our degrees of freedom was 11 because it was sample size minus 1, 12 minus 1. It is a left-tailed test because that's where our alpha was at. So it's a left-tailed test. And then we specify our test statistic, negative 4.553. Now, you'll look right here, ladies and gentlemen, is our p-value in percent form. Okay? It's not, a probability value has to be between 0 and 1. It's not a percent. So how do we get that into a p-value form? Ladies and gentlemen, we just move the decimal 2 places to the left. Right there, and there's another 0. So, let me grab my paper from my desk. The probability that we would get a test statistic that is more extreme than what we got from our sample data would be 0.0004. Okay, so I'm going to go back and write that now on what we just did on our work here. So ladies and gentlemen, our p-value that we got is over here. Let me change color. Is right here. Our p-value was beyond the 0.001 because it was actually 0.0004. In other words, what that is, that's actually 4/10,000ths. This number right here is actually 4/10,000ths, meaning if we took 10,000 samples of the same size from the population, then, ladies and gentlemen, only 4 of them would be more extreme than we are. That's definitely less than our alpha of 0.01. So our p-value here In other words, we have data that is very extreme. Not by just chance fluctuations, but possibly by the value. The reason is the mean is not going to be 9.02. So our p-value here was equal to 0.0004. And ladies and gentlemen, that p-value is less than alpha. Now, by the way, finding that p-value, that was step G in our process. And then, so finally, step H, we write the conclusion. So I'm using different colors, but it just maybe to separate things. So, because the p-value is less than alpha, we reject the null. In other words, what we're saying, ladies and gentlemen, is that there's enough, our evidence is strong enough from our sample to say that we're going to reject the null. And we're going to say there's enough evidence to possibly say that the alternative is true. So how do we write that? Well, we just write it as there is sufficient evidence that the average, because we're talking about average of a sample, the average, I keep thinking hippopotamus here, hippocampal volume in alcohol adolescents is less than, now you just state what your alternative hypothesis was, your H sub A. The normal value, or excuse me, the normal volume of 9.02 centimeters cubed. So basically what this is saying that now again, we can't, our evidence was strong enough. Only 4 out of every 10,000 samples would be more extreme than ours. That's really, 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 really extreme. So we're saying the evidence is strong enough to say, by our sample data, it was extreme enough to say that this wasn't caused by chance fluctuations in the sample data. We believe that this evidence is strong enough because the volume in these alcoholic adolescents, their hippocampal volume did decrease from their alcohol use. And ladies and gentlemen, that shows that people, alcoholic adolescents, in other words, adolescents who drink a lot, ladies and gentlemen, probably suffer from long-term memory lapses more than the average just healthy adolescent does. So, okay, that's the first example. We've got 2 more, and we'll go from there.